I'm Anil Kumar. This video is for my student Anna, who wants to understand how to find derivatives of exponential functions. So we'll have this as a three-part series. In the first part, I'm going to discuss simple derivatives of exponential and logarithmic functions. In the second part, we will look into applications and how logarithmic derivatives can make our job simpler. So let's begin by taking a few examples on derivatives of exponential functions. Question number 1 here is, slope of tangent line at x equals to 0 for f of x equals to e to the power of x is what? 4 choices are given to you. X equals to 0, that's the graph of e to the power of x. So that means we're looking at this point. So you could always draw a tangent line here and find the slope to match, correct? As you can see clearly, the slope looks like 1, right? So that becomes an option. Now, it is important to understand that derivative gives you the slope. So let's write down derivative of all the functions related with exponential functions. So if y equals to e to the power of x, then what is the derivative? It is exactly e to the power of x, correct? So in this case, x is 0, so we are looking for e to the power of 0, which is indeed 1, right? Now let me take this opportunity to write other derivatives of exponential functions. If you have y as equals to e to the power of f of x, let us say, in that case derivative will be e to the power of f of x times derivative of f of x, correct? At times you may have functions which is something base to the power of x, correct? In that case, the derivative could be, so if we are talking about some base, you may have to convert that to ln natural log function and then find the derivative. So what you get here is b to the power of x times ln base, the b itself, right? So that becomes the derivative. If your function is b to the power of g of x, let us say, so in that case, the derivative will be the function itself, b to the power of g of x, times ln b, the base, times the derivative of the function, correct? So normal rules, so power rule will be applied. Now you could also have questions related to y equals to ln x. Then the derivative of ln x is 1 over x. And if we have y equals to ln of g of x, let us say, then the derivative will be 1 over g of x times derivative of g of x, correct? Now, I will have questions related to log also. So the formulas which you may need are right here. While u is a function of x, let me write u as a function of x. In that case, this derivative is going to be 1 over the whole thing, which is u of x, times ln a, the base, and times the derivative of the function, correct? So these are different formulas which will be used in solving these 10 multiple choice questions, correct? So let's move on now. Question number 2. Slope of tangent line at x equals to minus 1 for f of x equals to e to the power of minus x is what? So we are given the function f of x equals to e to the power of minus x. Derivative will be what? Derivative is e to the power of minus x times the derivative, which is minus 1, right? So just write minus, correct? Now we are looking at derivative at x equals to minus 1. Substitute minus 1 here. So if you substitute minus 1 here, you get e to the power of minus 1, correct? So that is minus e. So option E is the right option. So it's kind of important at times to just do it, right? Now you could estimate it using different ways, sketch graph also, but that takes longer. This is probably the shortest way of doing it, right? So I hope that's clear. Let's move on. Here is question number 3. So we need to find derivative of this function, just match them. So we know y is equals to square root of e to the power of x plus 2. So the derivative will be the square root function. So 1 over 2 times the function itself, which is e to the power of x plus 2, times derivative of this function, which is e to the power of x, correct? So we're looking for e to the power of x in the numerator and 2 times this in the denominator. So option B is the right option. Question number 4 here is find derivative of 3 to the power of 5x plus b, right? So you could use this formula, said if you have y equals to b to the power of x, then what is the derivative equals to? The function itself, b to the power of x, it is a function of function. Is that okay? So in this particular case, ln b times, I should have written here f of x, right? So it is f of x times derivative of f of x, correct? I hope you understand. So basically the derivative here will be what? The function itself, which is 3 to the power of 5x plus 4 times ln b, b is the base, correct? So ln 3 times the derivative of the function, which is 5, right? You can reorganize it. So 5 constant, and then we have ln 3, and then we have 3 to the power of 5x plus 4, correct? So beginning with 5 ln 3, 3 to the power of 5x plus 4, option D is the right option. Question number 5. So I hope derivative part for exponential function is absolutely clear. Now let's move on to few application questions. At what value of x does this function have a critical number? So what is a critical number? Critical number or a critical point is when the first derivative is 0 or it does not exist. Is it okay? So let's find the derivative of this function. It is, we have to apply the product rule, right? So derivative of the first part is 2x times e to the power of minus x plus, we'll write first part as such, derivative of this function, which is e to the power of minus x times derivative of exponent, which is minus 1, correct? So we get here all this. I could write minus here. So let me take it in 2 steps now. So we have 2 to the power 2x times e to the power of minus x minus x squared plus 1 times e to the power of minus x. Now e to the power of minus x can be taken common. So we have 2x minus x squared minus 1, correct? So that's what we get. It's a quadratic equation. We could write this taking minus common. We could write minus e to the power of minus x. I'm just rearranging. I took this negative outside. So signs inside will change. Perfect. Now here, this could be written as minus e to the power of minus x. Now this function can never be 0. And whatever quadratic function you have here, we're looking for a product of 1. And when you add, you get minus 2, which is x minus 1 whole square, correct? So we have x equals to 1 as critical number. So idea is also to understand all the concepts as we move along. So the critical number is at x equals to 1. So I hope that is absolutely clear. Let's look into question number 6. We are already halfway through. However, later questions are slightly more difficult. The derivative of this function is what? So now we have combination with ln and e. So let me rewrite this function. We are talking about ln e to the power of x times square root of x, correct? Now you could actually apply the logarithmic rules and then do it. So I'll use 2 different methods to solve this question. I could write this as y equals to ln e to the power of x plus ln square root of x. Does make sense to you, right? Now ln e to the power of x basically is just x. And here we do have ln square root of x. Now if you want to find derivative, you get 1 plus ln derivative is 1 over the function, so 1 over square root x times derivative of this function, which is 1 over 2 square root x, correct? So what you get here is 1 plus 1 over 2x, correct? Well, you could match this answer by taking common denominator of 2x, so you get 2x plus 1. So option number 1 is the right option. Well, at times, if you don't want to do this, you can apply the rule as such. So let's do it without splitting it. So we'll redo this. So y dash is, whole thing comes in the denominator. So it is 1 over e to the power of x times square root x times derivative of the function, correct? So we'll apply the product rule. So derivative of e to the power of x is e to the power of x. So it is, let me write here, e to the power of x square root x, right? That is the first part, plus we'll maintain e to the power of x and write derivative of square root of x, correct? Which is 1 over 2 square root x. Is it okay? Okay, so this is in the numerator. Perfect. So you could write this as e to the power of x is common, correct? Take common denominator of 2 square root x, multiply this here, so you get 2x plus 1, correct? So that becomes the numerator divided by e to the power of x square root x. Now here e to the power of x, e to the power of x cancel. What you get here is 2x plus 1 divided by 2 square root x times square root x, which is same as 2x plus 1 over 2x, correct? So you get the same answer. So either way you do, you get the same answer. Question number 7 here is, determine concavity of this graph at x equals to minus 1. So concavity means you have to look for second derivative, correct? So we have the function y equals to x e to the power of 4x plus 1. Let's find the first derivative first. So derivative, we are using the product rule. So we get e to the power of 4x plus 1 plus x times e to the power of 4x plus 1 times derivative, which is 4. Okay, so now we will find the second derivative, which is, this function is 4 times e to the power of 4x plus 1, right? Plus, here we'll apply the product rule again. So 4 times x, I'm taking that as one number, times this derivative. This derivative is e to the power of 4x plus 1 times 4. So I took this derivative first, and then we'll now add derivative of 4x, which is just number 4, e to the power of 4x plus 1. Okay, we need to find concavity at x equals to minus 1. So what we can do here is substitute minus 1. You could simplify. Okay, so let's simplify. E to the power of 4x plus 1 is common. So what we get here is 4 from the first term. Second term gives us 16x. And third term again gives us plus 4, right? So that's what we get. Now if I substitute minus 1 here, so that means second derivative at x equals to minus 1, I get the first term here, which is e to the power of minus 4 plus 1, correct? And then what we have here is 4 plus, I should write 8, doesn't matter, 4 plus 4, and that becomes minus 16, right? So you see this part is negative, correct? So we know this part is always positive. This is always positive, this is negative, and so what we get is less than 0. So if it is less than 0, that means concavity is kind of like this, correct? So we have concave down at x equals to minus 1. Perfect. So till now I think it's all easy. So I hope it is okay. Feel free to write your comments and share your views. Question number 8. Determine the absolute extrema of the function y equals to x minus 3 times e to the power of x on the closed interval from minus 1 to 3. So in such functions, we have to find the critical number, first thing, right? So let's find the critical number. That is that the derivative is equals to 0, right? Or it does not exist, or it does not exist. That will be the case for sharp corners and cusps. Okay, so y derivative is, we'll apply the product rule. Derivative of x minus 3 is 1. We get e to the power of x plus x minus 3 times e to the power of x, right? So in this case, we can take e to the power of x common. We get 1 plus x minus 3, which is e to the power of x, and here we get x minus 2. Now that is equal to 0 means x equals to 2, right? So x equals to 2 is a critical number. Now extrema is going to be at critical number or at these points. So what we need to do is to find the value of our function. Let me write f at minus 1. This is what we have to calculate. The value of the function at the critical number 2 we have to calculate, and the value of function at the other extreme point 3 we have to calculate, correct? So let's substitute here. Minus 1 will give me minus 1 minus 3. Okay, I want to write minus 4, e to the power of minus 1. For the second one, it gives me 2 minus 3 to the e to the power of 2, and for the third one it gives me 3 minus 3 e to the power of 3, right? So that is 0. Okay, and here we have minus 4 over e, and here we have minus 1 over e, minus e square. Is that okay? Minus 1 e square. Perfect. So let's calculate these values. Clearly we have an idea now. Okay, so we have 4 divided by e, which is this, and that gives us negative 1.47, and then we have negative value. We'll do e square first, right? So we have so we have e square. We'll just make it negative, which is minus 7 point, I can write this as 4, and this is 0. So here what we see is that 0 is the maximum value, right? And this is the minimum value. So minus 7.4 is minimum, maximum is 0. Option B is the right option, correct? So if you want to find absolute extrema, you have to check the critical number and the values of the function at critical number and the two endpoints of the closed interval. Question number 9 is an application question. The decay of certain substance is modeled by the function n of t equals to 100 times e plus 3 plus e to the power of minus t over 3, where the number of particles is represented by n in a time of t hours. How fast is the number of particles changing when t equals to 3? That means we have to find the derivative of the function at t equals to 3. So let's first find the derivative. So inside part derivative, so it should be 100 times derivative of 3 is 0, correct? And derivative of this function is minus t over 3, minus 1 over 3 e to the power of minus t over 3, correct? So that becomes the derivative. Now we have to find the value at t equals to 3. So just substitute 3 here. So we get 100 with a negative sign times 1 over 3 e to the power of minus 1, correct? Because t is 3. So let's calculate this answer. So definitely it is negative, and we have 100 divided by 3 times, let's do 100 divided, oh my god. So let me clear this all. So we have 100 divided by 3, and then we'll divide this by e. Is it okay? E. And so what we get here is minus 12.26. So minus 12.26 means option B is the perfect option, right? Question number 10, which is also our last question. We need to determine the equation of the tangent to the curve defined by y equals to ln 1 plus e to the power of minus x at the point where x equals to 0. So to find the tangent, let's find the slope first. Slope means derivative at x equals to 0. So derivative of this function is ln of this means 1 over all this, 1 plus e to the power of minus x times derivative of the function, right? So it is minus e to the power of minus x times minus 1, correct? So that becomes the slope. Derivative, let's find this at x equals to 0. So if I substitute 0 here, I get 1 over 1 plus e to the power of 0. That negative makes it negative. E to the power of 0 is 1. So what we get here is negative 1. E to the power of 0, so negative 1 over 2. So we get slope of minus half, right? Now, if I substitute 0 here, what is the value of y? We should find this also, right? So for x equals to 0, y equals to ln 1 plus e to the power of 0, which is ln 1 plus 1, which is ln 2, right? Therefore, now we have slope m equals to minus half, and the point is 0 ln 2. Perfect. So the equation which we can use is y equals to mx plus b, where we know what m is. So we can write this as, let me do here. So we have y equals to, slope is minus half x plus b. To get the value of b, I will substitute y as ln 2, right? ln 2 equals to minus half x value 0 plus b, correct? So that is the y-intercept ln 2. Perfect. Since that is the y-intercept ln 2, that implies b equals to ln 2. We have our answer, which is y equals to slope of minus half x plus y-intercept ln 2. Does make sense to you, right? So that is what we are going to do. So what equation? ln 2 minus half. So the first one has been written in the other order, but that is what it matches. Perfect. So I hope with this you got a good start on understanding exponential functions, their derivatives, some applications. Now you should be ready to take up the next two tests, where we'll get into details of exponential as well as logarithmic functions. I hope you enjoyed this journey. Feel free to share your views and comments. If you like and subscribe the video, that'd be great for me. Thank you and all the best.